All right, some cool limits in this one. In case you're confronted with limits where we cannot use our limit properties or the ideas that we've talked about before, we should still be ready to basically tackle some other conceptualizing ways that we can rock these things. So that's a long-winded way of saying, let's do some interesting limits as x goes to infinity. So this first one says find each limit. The limit as x goes to infinity of 2x minus 1 over the square root of 9x squared plus 2x minus 4. Now I have the same problem here, except we've got the limit going to negative infinity, which we'll get to shortly. How do we solve this? What I do, which is actually a lot like what we did earlier in the first video of this lesson, is I plug in infinity. And again, I'm only going to pay attention to the highest powers in the numerator and denominator, because when I plug in infinity into 2x minus 1, the minus 1 doesn't matter. So I look at that and I say it's approximately the limit as x goes to infinity of, the only thing left here is 2x, all divided by, the 2x minus 4 in the denominator don't matter that much because again, we're going to infinity. So you've got the square root of 9x squared. That simplifies down nicely. So, and we'll see that shortly. So if we plug in infinity, you essentially have, well, let's take another look at this. We're going to have 2 times infinity over root 9 times infinity squared. That's not very clear, so let's simplify a little more. The square root of 9 is 3. The square root of x squared, that's a funky one, but it's the absolute value of x. You might remember that from Algebra 2. I hope you do. It's the idea that if I have a number and I square it, whether it's positive or negative, I'm going to get a positive value of x out. I'll never get a negative value out of the square root, hence the absolute value. So if we look at this, as we're going to positive infinity, essentially this is a positive x value, because we're going to a positive number, another positive x value, they divide out. And so that leaves you with 2/3. And that's our answer. Not bad. The limit as x goes to negative infinity, we're going to do something similar. So again, we're going to have the same logic. We'll get us down to the limit as x goes to negative infinity of 2x all over the square root of 9x squared. And as we looked at before, that simplified down to the limit as x goes to negative infinity of 2x all over 3 times the absolute value of x. Now, this absolute value of x is important in this case. Here it didn't really matter, right? We were going to positive infinity, so it might as well have just been 2x over 3x, because the absolute value of a positive number is just that positive number. But here the absolute value of a negative number, it takes the opposite sign of that number. So this is essentially like saying 2x over 3 times the opposite of x. Because any negative number that's plugged in there, we're taking the opposite sign of it. And that simplifies down to the x is dividing, and you're left with negative 2/3. So if you're looking at the graph of this, it's actually pretty cool. We end up with 2 horizontal asymptotes. As we go out to the right, we get y equals 2/3. As we go out to the left, we get y equals negative 2/3. So a couple of more challenging limits there, but I think that if you do it conceptually, you'll be in fine shape. All right, a couple other conceptual type problems are ones that involve trigonometry, and they are rad. Let's dive in. So find each limit if it exists. We've got the limit as x goes to infinity of the cosine of x. So essentially I'm just going to plug in infinity, and something right away kind of triggers my brain to think, wait a second, let me look at the unit circle, just a rough sketch of it. If I look at the unit circle, essentially it's like I'm going around and around and around because infinity keeps growing. So we never actually settle on one value. So this does not exist. It doesn't go to infinity or negative infinity, right? Because the highest value the cosine can be is 1, and the lowest value can be is negative 1. And if we take a look at it graphically, that makes a lot of sense too. Here's a rough sketch of cosine. Just goes on and on and on in either direction like that, right? It continues to go on. And if you look at it, the highest value is 1, the lowest value is negative 1, but we never make up our mind as we travel infinitely long. We're just going to be going up and down, never settling on one finite value, therefore making the limit not exist, due technically to oscillation, right? Changing values. Very cool. So I'll put oscillation because, heck, it's fun to spell, peeps. All right, so the limit as x goes to infinity. Are you ready for this one? I think you are. Of cosine x over x. Well, I mean, we could plug in the infinity if you want to. Let's see where that leaves us. Cosine of infinity all over infinity. Now technically we're not plugging in infinity, but the idea here is that you've got a number now, so some number, cosine of infinity, don't know what it is, but it's going to be between 1 and -1. We just talked about how it changes between the two values, and it could be any number in between. And that number all over infinity. So think about this. We don't know what the value is going to be in the numerator, have no idea. But we do know that it won't be more than 1 or less than -1. So it's finite and small, all divided by a massive number, infinity. So that means that we're going to go to 0, right? A relatively small number over a huge number, we're going to equal it out to 0. Now, just in case you want to see it done formally, this is pretty cool, we can use the Squeeze Theorem. What that basically says is we're going to build ourselves to this understanding. So we know the cosine of x is between -1 and 1. Those are its minimum and maximum values. We're going to build ourselves to this and sandwich in the value. We want cosine of x over x, so we're going to divide everything by x. So now what we've done is we've built ourselves up to the point where we have the expression that we want. So now we'll take the limit of everything. So if we take the limit of each individual term, the limit as x goes to infinity of -1 over x, the limit as x goes to infinity of what we want, cosine of x over x. And last but not least, the limit as x goes to infinity of 1 over x. Well, the limit as x goes to infinity of -1 over x is 0, -1 over huge. We don't know what this limit is. We have no idea. It's pretty rad though, I know that. And then on the right side here, the limit as x goes to positive infinity, that's 1 over huge, that's 0. So there's nowhere for this limit in the middle to go but to 0. So therefore, the limit as x goes to infinity of cosine of x over x has to equal 0. That is known as the Squeeze Theorem. We never used the Squeeze Theorem before. We only referred to it earlier. I believe that was in section 3 in this chapter. All right, that's it for some of the more advanced conceptual problems. What I've got left in this lesson is how to solve limits formally, not using the conceptual that we've done. Some professors and teachers prefer that. I'll go over that one with you next. Stoked for that.